Good morning, everyone. So nice to see you here bright and early, which is, by the way, a bit of a lie because it's very bright down here, so I can barely see you. But I see your gleaming badges at least, so good to have you here. The next decade of software is about climate. What is the role of machine learning? This is a chart over the global atmospheric CO2 concentration since the year 0. I was born here at 359 parts per million. My parents were born at 320 parts per million, and my child will be born at 420 parts per million. Great, now we all remember how an exponential curve works, in case you had forgotten since high school math. Good to start the day with some math. What that means is that we have been aware of the rapid rate of climate change since I was born, since before you all were born as well. In fact, when I was born, we deemed it so important that we taught this to kids in primary school. I cannot remember a time in my life where I was not aware of climate change. And there is scientific consensus that the amount of greenhouse gases that we as humans are responsible for emitting into the atmosphere is causing our climate to rapidly change. So the question then becomes, what does this have to do with machine learning, if anything? The age of AI has begun. Bill Gates wrote this in his blog Gate Notes March of this year, and he said that artificial intelligence is as revolutionary as the mobile phone and the internet. And as someone, I'm gonna again give away my age, someone who barely remembers a world without the internet or mobile phone, this is quite a statement. And there is no denying that we live in the age of AI and machine learning. Never before has it had such a profound impact on our lives as it has right now. AI is making splashy headlines in all areas of life, from art to medicine to warfare to school papers to climate. Here's another quote from Bill Gates from his Gate Notes. He did an AMA on Reddit where people can ask anything. Someone asked this very charming question: climate, are we effed or are we super turbo effed? And he had a lengthier response, basically saying the pace of innovation is picking up. It's not really going fast enough for us to meet the Paris Agreement of 2.5 degrees increase, but he still believes that we can avoid a terrible outcome. And I believe the same. A lot of people do believe the same. So that is what this talk is all about. How can we avoid the terrible outcome, and how can you help? How can we, as software practitioner, wherever your role is, if you're an engineer, data scientist, PM, manager, whatever your role is, how can you contribute to avoid that outcome? Great, so who am I and why am I talking about this? My name is Sara Bergman. I'm an individual contributor at the Green Software Foundation, where I've been since we were founded almost exactly to the day 2 years ago, which is kind of fun. I work nowadays primarily in the standards working group, where we're working to build standards for how you measure and look at software and climate, like the carbon footprint. In the beginning, I was also the chair of the writers group, so all the articles, newsletters, all the written material went through my group. My day job, however, is a senior software engineer at Microsoft, where I work with Microsoft 365 products. I'm an author of the O'Reilly book, Building Green Software, which just relaunched in early release. So if you want to go check it out, it's now available. I'm a Swede living here in beautiful Oslo, Norway, a distinction that is very important to us Scandinavians, even if it might not be to the rest of the world. And software and climate is a passion of mine because, like I said, I've been aware of climate change my whole life. It's not a great feeling to be told as a kid that, yeah, we're going to a dark place. I don't buy into that. I think that it's better to be part of the solution, and we have every opportunity to be part of the solution. When I was younger, I thought you had to work with whales, with climate science, be very hands-on in chemistry and biology, for which I have zero talent. So I was bummed that I couldn't be part of it, but then luckily found my way and realized you can actually contribute no matter what your job is. So in the next, however long we have together, this is what we will talk about. We will talk about machine learning and emissions, and why this is even an interesting thing to talk about in the first place. After that, we will talk about measurement. How can you measure the carbon footprint of your software? Because if you don't know your size, it's very hard to know if you're working to decrease it or increase it. And of course, the chunkiest part of this section will be mitigation approaches throughout the ML lifecycle. So I will give you some, or try to give you as many hands-on tips as I possibly can cram into this short time, so that you leave here with the tools to avoid that terrible outcome. This is about climate action. This is not a doomsday scenario. I promise that was the only scary graph. I'm gonna, maybe not. I'm taking back that promise. It was the scariest graph, at least. And then we're gonna have a bit of time for a Q&A at the end as well. So let's jump in. Why software and climate interesting to talk about? So this is a paper from 2018 where they compared and extrapolated the carbon footprint of the information communication sector. So they said that in 2007 it was like 1.5%, and they expected that by 2040 it would surpass 14% of the greenhouse gas contributions, which amounts for around half of the transportation sector. Granted, this paper is now 5 years old. Can you really rely on extrapolated data? And that's a whole conversation in and of itself. But we have seen massive growth in our industry during this time period due to some events that happened in the early 2020s, which we all remember and still recover from. But what I really like about this paper is the comparison to the transportation sector, because this is something we talk a lot about when we talk about climate. We talk about, like, buy things locally. Don't buy strawberries like shipped in from the Netherlands. Buy Norwegian strawberries that's from here. Don't fly, then you will be shamed on social media. But no one ever shames you on social media for using social media or for watching Netflix at night. We don't talk about that rarely in the context of climate. I see that it's changing a little bit, but historically we've been like flying under the radar completely in terms of climate change. But we do have a growing impact on society. But this talk was about machine learning, so let's talk about machine learning. This is a paper called Energy and Policy Consideration for Deep Learning in Natural Language Processing, and it's from 2019 by Struble, McCallum, and Ganesh. And what they did here was they took a bunch of popular, what they called off-the-shelf NLP models, and they calculated the carbon emissions and energetic cost of these models and then compared it to everyday stuff. And this was the biggest model they had in their paper at the time, which was Transformer with 213 million parameters with neural architecture search. And they found that training this model one single time, no data collection included, no actual use of this model included, just the one training, would emit as much carbon as 5 times the lifetime of an American car, which was mind-boggling at the time, because this was really the first paper, at least to my knowledge, it's heavily cited, which actually did this, which actually looked at machine learning and compared it to something that people could relate to. And people had lots of feelings about this, which is fine. But one of the things that people said was that this is an incredibly expensive model. Like, no, people aren't going about spending this much money on like a casual Tuesday training a model. This is an unrealistic view of our industry and our sector, because this model is so big. Fast forward 4 years since this paper was written. Remember this number, 213 million parameters. Now model size is looking like this. So this is a chart from an article in Ars Technica. I have all the links in the end, so I will share them on Slack, so don't worry, you don't have to remember them. Notice that this scale is logarithmic. Model size is exploding. We talked about 200 millions being a huge model in 2019. Now the huge models, they have 200 billion parameters instead. So it is interesting to talk about climate and software because our industry has a growing footprint. No, we're not the worst in class, but to reach the goals that we have set as a community for 2045 and 2050, then everyone needs to reduce their footprint. And just because someone is worse doesn't mean we can fly under the radar. We are also relatively few people who make up the builders of software. Other industries, they have a lot of contributors, but realistically, the software industry doesn't have that many people. And that's a good thing in the sense that we don't have to change the mind and ways of operating for that many people to actually dramatically have a positive impact, which is a good thing. So software is interesting, but machine learning is also interesting for two reasons. Model size is exploding. We also saw that in the keynote yesterday. But also the use cases and how much we use machine learning is also increasing. These are two studies from late last year, one by Deloitte and one by McKinsey. They're both called The State of AI, which is very convenient, so don't have to remember two names. But what Deloitte found was that 94% of business leaders think that AI is critical to success in the next 5 years. And that 79% of leaders, they had reported a full-scale development of 3 or more types of AI applications. And that's up from the year before, where it was only 62%. McKinsey found similar numbers. They found that AI adaptation had more than doubled between 2017 and 2022, and that the number of AI capabilities used by organizations also doubled between 2018 and 2022. So that means not only are we building larger and larger things, we're also infusing it into more and more areas. And that makes it interesting. And at this point in time, people usually feel, but can't we also do great things with software? Can't we also help decarbonize other parts using software? That's a very fair point, and absolutely we can. So it makes sense to talk about the difference between the two. Carbon footprint is a term I think a lot of us have heard, have some kind of relationship to. It's the size of your actions on the size of the impact of your actions on climate, and be that you as a private individual, you as an organization, or you as a country. It sort of scales that way. The carbon handprint is a little less used, but I think it's quite nice. It's also because hand and footprint, they match, but so I'm going to use it in this talk anyway. And that is the size of the actions that you take to decrease other people's footprints. So if you have a big handprint, that means you're decreasing someone else's footprint. So these are the good things you do in the world, which is great. And they map to software kind of like this. So when we talk about green software, we talk about how we can decrease the footprint, how we can minimize the negative effects on our climate by software. When we talk about green by software, we talk about all the cool things that we can do with software that helps decarbonize other sectors and other parts of the field, so making cars more fuel efficient, or monitor coral reefs, or using virtual meetings instead of flying across the world, for example. Because of course, software can, should, and is an enabler of climate solution, and it can be used to accelerate the decarbonization, really across any sector and any technology. And we do need people to focus on doing that as well, and it's super important, so don't lose sight of it. However, it's not the topic of this talk, but it's a great topic for another talk. So at this point in time, I also wanted to mention a bit about the Green Software Foundation, because you might not have heard of it. And we, like I said, we're celebrating 2 years around these days. And we try to represent the software industry. And our vision is that of green software. So our mission is to change how we build software so that there are 0 harmful environmental effects of software. And we try to do this by creating this trusted ecosystem of people, standards, toolings, and best practices for building and creating green software. Because it's awesome if one person or one organization or one institution comes up with something that is awesome. But it's even better if we can come together as an industry and say, you know what, we agree on this. We all think that this is the best thing to do, and this is our recommendation. That doesn't mean that the foundation should produce everything, but it can provide a lens or a platform to showcase work of others as well. We primarily serve what we call software practitioners. So even though I'm an engineer, not only engineers build softwares and are the makers of software. It's a much more diverse field than that. And secondarily, we support policy leaders, students, anyone in a software adjacent role. All right, cool. Hopefully you're on board with the fact that this is an interesting thing to talk about. So next thing I want to talk about is measurement. Because if you cannot measure it, it's very, very hard to improve it. At least if you have to work and operate in some sort of corporate world, we have OKRs and key metrics, and you have to report on progress per calendar year or quarter or week or whatever your cadence is. And then a number is very helpful. It's hard to say, my gut feeling is this is better, so I think we should do it. No CVP has ever agreed to that, at least no one I've met. So it's also a question that I get asked a lot. How big is my footprint? What's the biggest part of it? How do I measure it? Because I want to start with the big, easy thing. I don't want to do the complicated thing for a small gain, and that makes sense. That's completely fair. So to understand how to measure software, we firstly need to talk about what makes software green. And here we have a term called carbon efficiency. And I'm going to say carbon a lot. I probably already said it a lot. But when I say carbon, I don't really mean only C in the periodic system. I mean carbon dioxide equivalents, which is one term which we can use to map all greenhouse gases based on their global warming potential into a single metric. Because again, not big on the biology, chemistry stuff. Other people are much better at that, so let them do that. And we can just talk about carbon dioxide equivalents. But that's a very long word. I'm not a native English speaker. I don't have the time, also the limited the room on the slides. So we're going to go with carbon. That's also what the industry. I'm not sure if it's because there's limited number on the slides that other people say carbon. I just think it's more convenient and catchy. But carbon efficiency means that we strive to emit the least amount of carbon possible through our software. And there are 3 key actions we can take to do that. The first is being energy efficiency. So use the least amount of electricity possible. Likely the first thing that comes to mind, especially if you've been living through the energy crisis in Europe the past year. This has probably been top of mind for you as well, if only for cost reasons. Electricity is a proxy for carbon. The more electricity you use, the more carbon is released into the atmosphere. Not a one-to-one proxy, and I'll explain why in a bit. But as far as proxies go, it's a pretty good one. The second action we can take to be carbon efficient is to be hardware efficient. And that means use the least amount of embodied carbon possible. Embodied carbon is the term we use for the carbon debt that comes with any physical object. So for servers, for example, we had to mine all the materials somewhere. We shipped them around the world, likely several times, and assemble them in this very energy-intensive process, and then eventually the server landed on your server room, or the phone landed in your hand, or wherever it was. And that carbon debt is already paid. We've already released those atoms into the atmosphere. So what we can do is to be mindful of that fact and make sure to use the least embodied carbon possible. The third and final action to be carbon efficient is to be carbon aware. Do more when the electricity is clean and do less when the electricity is dirty. Because not all energy grids are created the same. Here in Norway, you may or may not know that we are very big on hydro. It rains a lot. We have a lot of water, which is good for hydro, and it's also a clean energy source. Other countries don't have this kind of uniform energy production. It's much more varied. That's more common around the world, that you have varying sources of energy. So your energy or your carbon intensity, how green or how dirty your grid is, it's going to fluctuate over time. And it's also going to fluctuate regionally. And being carbon aware means we utilize that fact. And we will look at some examples of what that means in a little bit. But great, so to be green, we need to be carbon efficient. How do we measure that? And this is where the software carbon intensity specification comes into play. The SEI is a rate of carbon emissions. It's not a total. And it consists conveniently of the three things we just talked about. So first, we have the energy that you emit through your software use. You multiply that with the location-based carbon intensity of your grid. So no market-based reductions allowed. And then you add on to that M, the embodied carbon of the hardware use that you have. And then you take all that and you divide it by functional unit R. And the functional unit in this case is anything that your software scales with. So it's highly specific to your scenario. It can be something like user, API call, ML training round, device, anything that really makes sense to you. And the beauty of this is that it can be used in any state of software development. So you can use it during the design phase to evaluate different options. You can use it in your maintenance phase to see if your actions had a positive or negative effect. And I said action a lot because it's heavily biased towards action. We want you to measure, change something, and measure again and see what impact did it have. Did it improve? Did it not improve? And again, I said measure a lot, but actually, let's talk about quantification, because you can totally measure it, but sometimes, say, if you're building a phone application, it's not really realistic to continuously send back energy information data from all those clients to your server just so that you can have a nice score. It might even consume more carbon that you can potentially save by having this knowledge. So we have two key ways to quantify your SEI score. The first, yes, is measure. You measure the total real-world carbon emissions of your software through, whatever metrics or whatever way you want to do that, and then you divide it by the total number of functional units. So like in the wild, observe, very easy if you have a server that's like physically located where you are, and in some other scenarios, but not always super convenient. So you can also calculate it. And then what you do is that you model what 1 unit of R would look like, and for the total, you calculate the total carbon emissions for executing one functional unit in a controlled lab environment, which sounds very fancy. I mean, build a benchmark application. And then you can compare that over time. So let's also talk about some core characteristics of the SEI, because the SEI is a living thing. We released the alpha version a year and a half ago, and our V1 version half a year ago, and it will likely be more versions than that because we're learning, the industry is evolving. But there are some core characteristics that should remain true. And the first is that the SEI should be sensitive to carbon awareness, energy efficiency, and hardware efficiency. We also take a system impact view, and that means we're not interested in local level micro optimizations. We want to decrease emissions across the system. And to do that, you need to be mindful of how your little component interact with the system so that the things that you do don't have negative upstream or downstream consequences. Thirdly, it should be easy to implement. Hopefully you already have an understanding just after me talking about this for a few minutes. We don't want you to have to take a course or certification to be able to use it. It should be easy to use so you can start taking action. It also encourages the use of granular data, simply because it gives you more levers. If you have more temporal understanding, so if you have a 5-minute slot trend, that's easier to act on than if you have yearly averages, for example. Also exclusions. I mentioned this a bit, but only actions that actually eliminate emissions can reduce your SEI score. That means that you cannot reduce it by market-based measure. It also means that you cannot go to 0. A lower score is going to be better, but 0 is impossible. And why is this important? It is because we want the SEI score to be part of your net zero strategy. You probably heard about net zero, probably heard about carbon neutral, climate negative. People like to say these words, and then they sometimes, but not always, understand fully what they mean. So say this black bar is the amount of emissions that you have. And to get to 0, you can actually eliminate all emissions by 100%. For software, that means you shut it down. So that's not very fun. At least, like, then we would all be out of a job, and the world would. I don't think the world would be a better place if we did that. So yeah, not super relevant for us, but that's what 100% eliminations mean. For carbon neutral, what that means is that your emissions are the same, but you neutralize or compensate 100 or more % of that emissions. And neutralizations are not permanent, but emissions are. Net zero, on the other hand, means that you eliminate, some say 90%, some say as much as possible, and then you only offset the rest. And net zero are the goal we have set for 2045 to reach that 1.5 goal. And this is the reason why market-based reductions are not allowed in the SEI score. They're not inherently bad. I'm not saying like never use them or that carbon neutral is a horrible thing. It's absolutely not. There are definitely merit to these economical measures. However, for people like us who just want to decrease the impact of our code, it's very hard to reason over if, was it my actions that had impact or was it just because I planted 5 trees? And those two are not the same, so we should not compare them the same in this score. You can use the SEI score to evaluate delta between 2 options. What I'm trying to do here is give an example of how it can be used in a machine learning context. So the SEI have a bunch of case studies, which again linked at the end. You can go check them out if you want to learn more. But what they did here was to calculate the SEI delta between 2 convolutional neural networks, so Inception and DenseNet. And basically what they found was this. So they have 2 models. They have different accuracy. And what they tried to do was temporally shift this workload in time. So say we're running on the same data center, but we can run it any time we like within a 24-hour time period. How much carbon could we possibly save? And then they used the SEI score and found that we could save 11.5% by changing not a single line of code, just changing when it ran. So this is one of the use cases for the SEI. Okay, great. Now we are on board with the fact that machine learning, climate is important. We know how to measure. We know what makes software green. Now the question becomes, how does this apply to our domain, which is AI and machine learning? Because green software is very domain specific. There is no magic silver bullet or one thing that everyone can do and then it would all be solved. Like that would be too easy, then I wouldn't be standing here. So what we're gonna do is we're gonna talk about some patterns. Because the Green Software Foundation have, and this is pretty new, it's just a few months old, but it's a patterns catalog, so there are a lot of AI patterns, but also cloud and web patterns. And these patterns are all reviewed by subject matter experts before they're published, and they're also agreed by consensus by all of the member organizations in the Green Software Foundation. You can submit your own pattern if you think you have one that's missing. There are probably many missing. Like I said, it's just a few months old, this catalog, so, and our field is ever growing. But those slides you will recognize because they will look like this. I will also talk about some things that are not patterns, but that are still good ways to reduce your impact. And we're going to use this machine learning lifecycle to sort of group the next section of our talk. You might have more steps in your lifecycle, or you may have fewer, only one step might interest you, that's okay. It's just a mental model that makes life a bit easier. So, first up, project planning. Project planning is a really great time to plan for green software because things cost very little to change on paper compared to when they're deployed on thousands of machines. So this is really the time to ask difficult questions. What is the impact of our system? How do we plan to measure it? Do we plan to measure it at all? And what is the scenario we're going for here? It's also a great time to discuss if you want to include any carbon-aware features like demand shaping. Think about demand shaping the way video conferencing work. So when you're in a video conference, the quality of sound and the video will change depending on your internet bandwidth. This is something that we kind of take for granted. We assume all software does this for us. And we can apply the same thinking to the grid intensity. So if the grid is really dirty, maybe we serve lower accuracy recommendations or less computationally intense tasks. And when it's green, we serve super high accuracy, for example. So project planning is a great time to start thinking about those things. It's also a great time to have candid conversations about SLAs and SLOs, because matching your service level objectives to your actual business needs is a great way to save carbon. Not matching them is a great way to waste carbon. Lower availability guarantees can really help reduce energy consumption because you're using fewer infrastructure components, and thus you're using less electricity as well. So the solution here is to adjust your service level objectives based on your actual business needs. Because if you don't need that super high availability, then you're just going to waste infrastructure components trying to deliver it to your customers. And the SEI impact is on the E, energy, and M, embodied carbon. Great, so the next phase is data collection. And data collection is interesting because it's often seen as like this less glamorous part of machine learning. Like people compare it to data is the new oil, or like panning for gold in like the gold rush California. And it's like all these very dirty references that I'm not sure how that happened or why people see data collection as not as fancy as other parts of the machine learning lifecycle. Because we do know that if you have data quality issues, they're going to have a cascading effect further on, such as reduced accuracy. So what does that mean for us? So when we build larger AI models, which we know we're doing, they need larger data sets to prevent overfitting and so that we are accurately representing the data we're trying to capture, which is a good thing. We also know that if we have large data sets, they can potentially be reused for other scenarios later on that we might not know about now, so we can become these data hoarders. These data sets can carry ethical implications, of course, like lack of informed consent or inability to withdraw consent. But there are at least 3 other talks on AI ethics in this conference. I'm not going to dive further into that because it really is a whole talk in itself. But we do know that data sets are growing. And that means that green data collection is becoming increasingly important. Even so, there is extremely little research in this area. So if you want to write a paper, I would be happy to read it. But something that we do know works for any workload that's not on demand, and data collection it's rarely on demand, is time shifting and region shifting. So shifting it to times that are greener, shifting it to regions that are greener. Another thing to think about is how much data do you actually need? And are there already open source data sets that you can utilize? Because if there is already data out there that you can use and reuse, then you don't have to spend additional carbon setting up a new collection pipeline to gather all this data anew. So apply the good old reduce, reuse, recycling thinking here as well. So the next phase in the life cycle is what people maybe call the actual ML part, the things that get the most attention in at least the scientific community, maybe in media, not so much. But yeah, I'm of course talking about training and design of models. So here we have a lot of examples and patterns and data as well. And I wanted to start by showing this graph. This is a linear scale, so we're not on a logarithmic scale. But this is a paper from this year by Elaine Suleiman, and she compared again the parameter size of AI models. And as you could see in the 2019-2020s, we were like at the bottom of this scale, which is relatively smallish. I would still argue it's still a lot of parameters, but they're not super big. And then we have increased exponentially. Also, you might see that the color have changed a bit. So we're going from more like open and downloadable data sets or models to these increasingly closer or semi-closed data sets, which is an interesting thing to be aware of. Because the first pattern has to do with training models more efficiently, and the first thing we want to do is to shrink the models. Because large models requires more energy, more resources to train. But the good news is there are a lot of research initiatives going on in this space that are exploring how we train models faster and more efficiently. And they rely on things like pruning, compression, distillation, quantization, which was also mentioned in the keynote yesterday, and federated learning. And there is one example called Can Federated Learning Save the Planet, which is a research paper with a very cool title. And they found that federated learning can be a bit slower to converge, but it's actually a greener technology than using the data center's GPUs off the shelf. So if you have a smaller models, you use fewer computational cycles, and you use less storage space, so you're decreasing the energy and the embodied carbon use. Also, with edge computing and Internet of Things, we're seeing more and more devices that have limited capabilities. They cannot host these super large models, so smaller models is really going to be the way to go here. This can also, by the way, be a great way to democratize ML research, because if we only have these huge models which are fully closed, we're really saying only the rich can contribute to the cutting edge of machine learning research, which is a shame, because there are a lot of people that out there who might not have access to those data centers that can do great things for research. And of course, this is also a pattern, so optimizing the size of your AI and ML models, and yeah, it saves energy because you're using less memory, and also but I forgot to highlight that, but I at least wrote it in the text. Great. So next thing is time shifting. What's important and what is urgent? They are not the same. People like to think they're the same, but they're really not the same. So delay what you can for green power, because machine learning training is very rarely urgent. There's very rarely someone say, you have to save someone's life, train this model now. Like, that's just really not the case. So you can absolutely wait for those greener times when fewer things are competing for energy resources. And you can do this by using spot or preemptive instances, or like flexible, burstable instances. A lot of cloud providers already have support for this kind of scheduling, so that's good. Fewer things to implement for us. And you don't have to change any code for this. You can still run your training in the same way, just at a different point in time. So the cousin of this is using sustainable regions for training. So that means you're not time shifting, but regionally shifting. That might not be possible for data sovereignty laws for everyone, but sometimes it definitely is. For example, just inside Europe or just inside America, you still have pretty varied energy productions around the area. So use a cloud region that has a lower carbon intensity for running your training workloads, and that will decrease the I, so the carbon intensity of your SEI score. Excellent. Hardware is another interesting topic to talk about. Can we use specialized hardware like ASICs or FPGAs or TPUs? They are often provided by cloud providers or cloud vendors, and they do provide better energy efficiency and inferences for AI models than the conventional chip, which is pretty cool. And that means, again, that you have these efficiency gain, which is going to save you energy. So you can evaluate and leverage the right type of hardware, or VM instance also, but we're primarily talking about hardware, to increase the energy efficiency and also embodied carbon of your solution. Now, this is kind of cool if you're on the cloud. If you're not on the cloud, however, you already have your own data center, or you're allowed to call a room of servers a data center in this talk. I make the rules. And you already have non-specialized hardware, so you already have a bunch of CPUs or GPUs that you're using. Then going off and buying a bunch of ASICs just so that you can increase your efficiency is not going to be the greenest option, because you're now spending a lot of embodied carbon on buying completely new hardware when you have perfectly working hardware that you can use. So having those kind of trade-offs is important to consider. There's no silver bullet that works for every solution, so just critically think about that. The next thing is to leverage pre-trained models. And then this, by now, I'm sure you're understanding the pattern. Do less, build on others is a great way to be green. But transfer learning doesn't require as many servers, does not as much energy, does as much embodied carbon, because the model is already pre-trained. You just have to tweak it a little. So evaluate and select pre-trained models and then use transfer learning whenever possible. Excellent. So that was the ML training part. Now we're going to talk about deployment and maintenance. And here I wanted to talk about Azure Machine Learning just for a little bit, because they have, it's maybe not so new now, it's a year and a half old, some resource metrics that allow you to monitor your ML system in near real time. And they can give you things like the energetic and computational cost of your model. So basically, you can evaluate over time how you're performing. So this is a great tool, so you don't have to build things from scratch, which we like. And if you're already using Azure Machine Learning, you can go check it out. They're not driving this alone. They're doing it in partnership with the Allen Institute for AI and with the Green Software Foundation. Great. In the deployment and maintenance phase, we're starting to go a little bit away from the highly ML-specific things into things that work for more types of software. And here it's really about variable power. And I mentioned this now a lot of times in the talk, but I want to say that this is good for two reasons. So firstly, if you use greener energy, like right now, you're emitting less carbon, like immediate gain. But also by placing your money into the pocket of renewable energy source providers, you're actually helping with the energy transition. So over time, this will also ensure that we get more renewable and low carbon energy providers on the grid. So it has like this dual effect, which I think is really cool. And using our spending power is not something that we should underestimate as software practitioners. So what you really want is a hosting provider that is committed to sustainable hosting. So if you're on the cloud, tell your cloud provider that you care about this. Tell them that this is important to you. If you're self-hosted, you can absolutely do this yourself. You can negotiate with energy providers, or if you're in a region that only has green energy, good for you. Typically, it's easier to move to the cloud, but you can definitely do it on your own. Also, if you're multi-regional, think about hosting in regions that have good options for sustainable electricity provisioning. Not every region in the world has this. It really depends on how their national grid is looking. And as again, we've seen in Europe in the past year, this can also change over time. The next thing to think about is to assess your hosting efficiency and use high-density managed servers when possible. Do you have a strategy for machine utilization? Is it good enough? Underutilized machines is a waste of embodied carbon, but also a waste of energy, which is just turning a server on, having it do nothing, still consumes energy. And after that, the more you utilize the machine, the energy consumption is actually not linear. So high-used machines means less energy is used and also less carbon, which is pretty cool. And you can achieve these high-density servers through different ways, typically through orchestrators or cluster schedulers like Kubernetes or managed. But the easier win here is looking at your old workloads, your old machines, turn them off. If you have zombie workloads, like machines doing nothing, they're obviously a huge waste. Introduce auto-scaling and right-size your machines. Another thing that you may evaluate is to adopt a serverless architecture for your workloads, because serverless gives you the benefit of just launching resources when you need them. So instead of the shift and lift to dedicated machines, you rely on your cloud provider to do some of the work for you. And this will decrease both the E and the M of your SEI score. Great. So the last pattern of today is running AI models on the edge. This can, of course, be used for training as well, but running inference on the edge is kind of cool because you reduce the network transfer to the cloud, thus reducing overall or decreasing overall energy consumed. And networks, like big data transmission networks, they actually consume a lot of energy. And this is, again, something we talk a little less about, but they're pretty heavy-duty equipment standing out there, sending our data across the world. They're using a lot of electricity. They're also using a lot of hardware. So, and the more data we send, the more carbon is released because of that energy used and because of that embodied carbon of that equipment. So being on the edge, you use less of the network, you're closer to your users. Maybe you're also running smaller models because you have limited capabilities on that device. All right, awesome. We made it through a lot of patterns. That was like a lot of tips. Hopefully you found one or two things that resonated with you and that gave you some idea of where to start. And the where to start kind of depends also on which phase your project is in and what kind of project you're really doing. Obviously, if you're still on the pen and paper stage, yeah, the project planning is where you want to get started. But otherwise, where you're spending the most carbon, it kind of depends. So if you have very large models where you need to gather all your data on your own, then looking at data collection is a good first thing. If you're trying to achieve super, super high accuracy with these cutting-edge models, or you have a research scenario, then likely training is where you're spending the most carbon. If you're, however, running like a more vanilla ML operations in production, so you're not the very forefront, which is okay, most of us are not on the forefront of research, but you're using it a lot in your product, then any number times a billion or however many requests you have, it's going to be a big number. So looking at deployment and maintenance is going to be key for you. All right, so what did we learn today? Well, we learned that AI and ML has a role to play in the climate solution. And what that role is in our hands. We looked at the Green Software Foundation's software carbon intensity specification, and we learned that you can use this already today to assess the carbon score of your product. We also looked at research and techniques that can be applied for you to reduce your impact. And if you thought that this was fun, but I want to learn more, this was a short time, great news for you. The Linux Foundation has a free course for, it's called Green Software for Practitioners. And it's an introductory course to green software where we will go through in detail some of the things that I breezed by today. So yeah, check that out if you are interested. And these are the links to the things that I talked about. I will post them in Slack as well so you can find them afterwards. But thank you so much for your time and attention. And now we do have some time for questions, if people have any. Yes?
Great talk, Sara. Thank you so much for spreading awareness on that. You shared throughout the talk a lot about carbon awareness and kind of time shifting and region shifting for carbon. What are your thoughts on the water footprint? Because this is something that has been under the radar for a long time. There is like a great research paper that was recently launched on this topic, which actually tells a lot about that if you time shift only based on carbon, this is not given that you can waste a lot of water due to that as well. So what are your thoughts on that, and should that also be included into the calculations during the planning?
Great question. I'm going to repeat it, so make sure I understand it also so people can hear it in the microphone. But the question was, carbon is interesting, especially when it comes to time shifting and region shifting, but what about water? We know data centers consumes a lot of water. There was a recent research paper, which I believe called Yes, How to Make AI Less Thirsty. Thank you, very good paper. And what are my thoughts on that? I captured it correctly? Yes, good. Yes, and it's, of course, very interesting question. It's also one of those things that are so highly regionable, because there are some regions in the world that have like the best sources for green energy production because they have lots of solar, but then they have no water, so they can't cool their data centers, because typically we cool data centers using air. It's used here in the Nordic, where it's cold, so that works kind of well. But otherwise, water is used, and that's also something we saw last year in Europe when there was a drought and unprecedented heat wave. You couldn't cool data centers. So I think it's very, very important to talk about. There are research initiatives going on. So there is something called liquid immersion cooling, which is basically, it looks very sci-fi, but you immerse entire servers into a liquid, but it's not water-based coolant. And there's like one phase and two phase. And the two phase one was just recently disallowed in both America and the EU because they use forever chemicals, which is a very scary word. But I believe the one phase liquid immersion cooling is still ongoing. So there are research initiatives. It's not going super fast, but Microsoft also sent data centers under the sea because then it's really cold, less need for water. So yeah, that was a long way of saying I think it's important. I think the industry are gaining more traction into this. And yeah, maybe it should be part of the SEI score, or maybe there should be a separate score, because for data centers, we have the power usage effectiveness. So how good are you at converting power into useful operation? They also have water use intensity. So it's the same thing, or water use effectiveness. So how much water do you use for your value, like for your operations? And it's like a ratio. And perhaps there should be an SEI score just for water, and you should combine the two. Not sure what's the best way, but it's definitely an important thing. Thanks for the question. All right, anyone else? Yes.
Hey, this question is more about software in general rather than ML, but I wonder like how much specific tooling plays a role. I think the best example would be like programming languages. Like we know that often languages like Python run way slower than stuff like C++. So does it have any significant impact too?
Yeah, good question. I'm going to repeat it again for the mic. But the question is, in general, does specific tooling have a role to play, specifically in terms of code efficiency, so moving to a more efficient language, for example? I captured it correctly?
Yeah. Right.
Good. Yeah, good question. Get asked that one a lot. Yeah, you can get a lot of efficiency gains from moving to a more energy efficient language. And it's also very tempting as a software engineer, if you have a favorite language that tends to be very efficient, you want to rewrite everything. However, it's not a perfect solution for a few reasons. Firstly, it costs a lot of developer efficiency if you're going to rewrite everything. Of course, if you have a new project and you have the option to choose your language, there's no reason, or there might be reasons, but if you have an opportunity to choose a more efficient language, definitely do it. However, if you have a system and you're going to overhaul it, it's going to cost your company a lot of money, and people are not going to be willing to spend that money, very likely. So it's a hard thing to sell. Secondly, if you're moving from a well-known language into something that's maybe a little less known, you might have issues with talent recruitment in the future as well. So again, something that your company might not want you to do. That doesn't mean it's not worth it, but typically the far easier wins can be found on the operational side. So think about how you run your application. Those are going to be the first thing that for many are going to be the most valuable. But yeah, general high performance computing tricks are great, and they do have a tested and proved for many years effect. So they're not bad, but you might get some resistance from your company leadership. Thanks for the question. All right, anyone else? Yeah, you can definitely ask one more question.
One thing I was wondering, once you mentioned about the kind of operational aspect and also like where you run your applications, most of us who may be creating them, including ML, may be running public cloud providers and may even use the ML models provided by cloud providers. What I feel is there is a lacking transparency on that from the public cloud providers, and sometimes it's really hard to find that data, and it's not even that a single person or a single company has enough power to kind of push the provider to make this data transparent. We've seen it with the OpenAI, which is currently, they're lacking a lot of transparency on the infrastructural side of things. So does Green Software Foundation have like any dialogue, or maybe like is there anything ongoing to kind of make that transparency better? Some public cloud providers are better than others at this, but if you know like any resources or anything.
Yeah. Yeah, so the question was about transparency, both from big cloud providers, but also on like these closed ML models that we talked about. If I summarize, yeah, great, yeah. Excellent question. And also what does the Green Software Foundation do with this? Yeah, so I think now all three major cloud providers, so AWS, Azure, and Google Cloud, they do have some kind of carbon emissions impact tooling, which they didn't just a few years ago. So that's a big shift we have seen. We've also seen that Amazon have received a lot of critiques for AVS. They're lagging behind, so they just said that in 2024 they would add a bunch of new stuff, including Scope 3, which wasn't in the model before. So I think as an industry, we're moving in the right direction with increased transparency. Of course, using your spending power to tell your cloud provider that this is important is always going to be a good way to get things moving, because, yeah, companies care about what their customers care about. So that's one thing. In terms of models and them being closed, I'm less aware of any ongoing effort there. I think it's because the field is exploding so fast, and because of the ethical side of it, I think many are hesitant to release models sort of into the wild. That doesn't mean you can't disclose some features around it, but no, I haven't seen as much ongoing there, which is a bummer. I would love to see it. From the Green Software Foundation perspective, we have a project called, is it called Open Data, I believe? Yeah, where they're trying to gather open source data of these kind of metrics to at least try and provide an overview of what's already there. I also know that Adrian Cockcroft, who previously worked for both Netflix and AVS, he's trying to do exactly that. He's trying to convince cloud providers to provide more detailed and more granular carbon data. So basically that you could monitor your system in very close to real time, which is an very interesting idea. I talked with him on QCon a few weeks ago. So I'm super excited to see where this land, but it's very much a brainchild at this point in time. But thanks for your question. All right, we have a few more minutes, so if there's anyone else. If not, then thank you so much for coming to this early morning session. I enjoyed having you here.